your plus from the building your form to calculate. So my u squared, that would be even constant plus anything y 3 squared. I have 5 plus equals. I drop negative 12. Then your 3a squares would cancel there. I'm going to go ahead and add 12a to sides. And I'm going to write this in standard form. So I have 5a squared plus 0. Pull out your a, b, c terms. Your a term is up squared, which is 5. Your term is 12. And your c term is 8. So again, writing things in standard form, your term. Now, once you pull out your term, you can go ahead and use the quadratic formula. Look how it can be written. Either way here, this side is saying that 2a is dividing into everything, including this negative b value. Some people like to write it like this, just hold the 2a over here, so know that really the term right here is written as a fraction. In example 2, we're going to solve using the quadratic formula. Notice, it is already in standard form, so what we want to do is pull out our a, b, and c values. In this case is 1, b is 4, c is negative 25. So now we'll use a simple substitution and put into the equation above. We have x equals, for negative, here's negative, well in for b, the term 4, over 2, and in for a is 1. A negative, square it, in for b squared, well b 4, so I'm going to put in and minus 4a c. And then this square root here is over 2a as well. A value is 1. And just simplify everything. We would get x equals 4 halves plus or minus square root 16. And then we would have plus 100 all over 2. Again, simplify well. We get negative 2 minus inside our square root 16 over 2. And we have x equals negative 2 plus or minus square root of 16. Find the square root of 16 in your calculator, divide that by 2, we get 5.4. Now, we can go ahead and simplify the last piece. Remember, this is basically saying negative 2 plus 5.4 and negative 2 minus 5.4. So we are going to come up with two x-intercepts again, and they would be 3.4 and negative 7.4. Those are my intercepts, my x-intercepts. Example 3, very similar to example 2. Why don't you go ahead and pause the video, try working through it on your own. Remember, the first thing that we need to do is set it equal to 0, so we need to write it out in standard form. So we have x squared plus 2x minus 8 equals 0. That's your first step. And then pull out your a, b, c values to plug into your equation. So a is 1, b is 2, c is negative 8. Now use those terms, substitute into your equation, check in periodically to see how you're doing. So pause it and work through it. Double check things here, but after your substitution, your formula should look something like this. After you substitute, next go ahead and reduce everything down. After we do our computation, our equation should look something similar to this, and then we'd wind up with x equals negative 1 plus or minus square root 36 over 2. So x equals negative 1 plus or minus square root of 36 is 6. 6 divided by 2 is 3. And then we get our two x-intercepts. Negative 1 plus 3 is 2. And negative 1 minus 3 is negative 4. There's our two x-intercepts. Example 4, again, go ahead and give this a shot here. We need to go ahead and write it in the form ax squared plus bx plus c equals 0. So the first step here in example 4 is go ahead and distribute, and we get 3x squared minus 12x equals 2. So we need to subtract 2 from both sides, and we have 3x squared minus 12x minus 2 equals 0. Pull out your a, b, and c values. A is 3, B is negative 12, C is negative 2, and then go ahead and input these into your equation and solve for your x-intercepts. Here's what it should look like after our substitution. Big thing here is notice I hold that negative and I substitute in for B. Next, go ahead and do your computation. Following our computation, here's what we have. Next, go ahead and reduce. And we get 2 plus a negative square root 168 divided by 6. Then we'll go ahead and take 2 plus a negative, the square root of 168 divided by 6 is 2.16. So we get our two x-intercepts at 4.16 and negative 0.16. This will conclude lesson 47, quadratic functions and equations using the quadratic formula.